Okay, I see lots of folks coming in. Appreciate you being here again for our next installment of our webinar series. This one on June 25th, 2020. As we're all getting coming in and getting in place, I'd like to welcome everybody. Thanks for coming. This is something we've been doing for quite a while, since the end of March, and been doing 2 of these a week and having a great time, hitting lots of topics. And we've got one here that's been requested by quite a few people hey, just give me a little bit more information on measuring performance. And we had such great feedback from our co-host today about our co-host today, Ray Phillips from Precision Driving Analytics, that we thought he was the perfect person to chat about this. So we're bringing him back for his second webinar, and so this will be a good time. So the couple of things as we always kind of chat about as we get started. Make sure on the chat box there that you go down and change that from all panelists to all panelists and attendees. If you don't do that, only the 4 of us that are here watching we'll see those. We'll see your messages. So make sure you change that. And the other one is make sure you open up your question and answer box. That is where we want you to type in any comments or questions that pertain to the live presentation of this material. If you have a question about something that Ray presents, you want to get a little bit more clarity, ask them different questions there. Make sure you type them into the question and answer box, and then we have a couple of folks. 3 folks on the back side here that are monitoring the chat box, and of course the question and answer. We've got Brick and Robinson from our Roanoke office in Virginia, and we've got Robbie from our California office in Lake Elsinore. They're back there taking care of answering tons of questions, saying hi to you in the chat box, and throwing up some links and some different things. So keep an eye on what they do back there. They'll be answering those questions. If they can answer them real quickly, they'll answer the Q&A box questions, and if not, they'll pass them over to Ray and I, and we'll see if we can answer those in. So make sure you do that. I appreciate that. As we kind of get started, I always like to start with one of our polls, and if you could take a look at that and give us an idea, what hardware do you use? AIM hardware to use. Select all that apply. If you have multiple pieces, do that. If you got something that's we only have 10 spots on the poll, so I can't list everything. So if, I did a SmartyCam/other there at the bottom. If you got something that's other that I don't have listed on there, go to the chat box and type other equals and type in what you're using. That helps us tremendously in understanding where we build future webinars. So I'll let that run for a moment. If you finish it, go ahead and just press on the submit button, and it should clear out of the way so you can see. But I'll let that run for about a minute, and then we'll come back to that. So, but first, I'd like to introduce our co-host today. Is a fellow by the name of Ray Phillips. Ray has been here and did a previous webinar with us, going further with track maps, which had been asked for quite a bit in another poll that we often do, and so he did that, and we had just tons of great feedback that was to any number of people, that was one of the best webinars we've done, that they've got the most information out of. So Ray is coming back today to talk about performance measures and how to figure that out a little bit. Ray met Ray probably 4 or 5 years ago. Some of the track day stuff that I do and some of the seminars that I've done. Ray's out of Durham, North Carolina. He's the owner of Precision Driving Analytics. Been involved in motorsports for a long time. A lifer, I suppose, at this point, right? 25 years. Data engineer for Ferrari Challenge, plus some other things. But 1 year in there, the team won the championship, so that's pretty cool. What Ray does is one of the things that he does that a lot of you may want to know about is he creates custom user profiles and math channels. So if you have a question at the end here, after the webinar today, that boy, you've got something in your head, and your imagination says, boy, I'd love to look at my data in this way, but I don't know how to get there. Boy, give or a math channel to how to create something. He's going to show you some interesting user profiles and math channels today. If you want to talk with Ray about those, we'll give you some contact information up there at the top left corner. There's his email address, and we'll have it on the last slide too if you miss it. And of course, you can always rewatch the video on YouTube once we put it up there here in about an hour after we finish. So Keep that in mind. I'm going to go ahead and end that poll right now, and ask Ray to give us just a little bit more information about yourself, Ray. A little bit more background than what we shared on that slide.
Well, there's probably not much more to it except that I love racing. It's always been a passion of mine, and I'm very analytical, so I really like the data aspect. As soon as data loggers came out, I knew that's something I needed to have, and my first data logger was like an AIM Micron Gold or something like that. So I've been using data for a long, long time. Use it with the simulators now too. So yeah, there's lots of ways to use the data, and I just like trying to figure out different ways to get more value out of it.
An inquisitive mind, right? And a problem solver. That's typically how we see our data folks, right? So perfect. Let me. We're gonna kind of just jump right in, right? So I'm gonna share a different screen. We're gonna look at some data, and kind of turn this over to Ray. Ray is we're going to chat about just some different ways to set up your screen, some different things. We'll do a poll in the middle. He's going to look at some different functions, some different data sets, so with that, Ray, let me give you control of the mouse here, and you should be able to click once in there, and it should be yours. Perfect. There you go, Ray. Take it over and show us some new things we don't know.
All right. So first off, we're looking at what I call lap compare profile, and it's all the basic stuff, and I use this a lot, and you can get a lot of value out of this. As Peter Krause says, the speed channel is a money channel. So that's definitely one thing to always look at. And as Roger says a number of times is what happened, where it happened, why it happened. And today we're going to talk a little bit more about why it happened, get down to that bottom layer. But I'm all about looking at data quickly, because many times I'm supporting multiple drivers. And I know a lot of club racers need to be able to look at data quickly as well, because they have to work on their car and get it out on the track again in between sessions. So some of the things I'm going to show you today are just different ways that you can come up with measurable goals. And some of these are going to be visual, and some of them are going to be concrete numbers. But again, they're going to be things that you can see very quickly and determine whether or not you've made an improvement or not. So almost everything we're going to look at today is using math channels. And the beautiful thing about math channels is that you're effectively creating another channel from channels you already have. So you're really expanding the amount of channels you have available to you. And there's certain functions that I use quite a bit that we're going to look at. Two main ones are integral and derivative. And then there's another one, lap integral and derivative are the two I use. And then there's integral as well. So the differences between integral and lap integral are that integral sums up all the data points over the entire session. Lap integral sums up all the data points over a given lap. So let me show you how I would use the integral function. I'll show you what this looks like as a math channel as well.
Yeah, we give those things big, long names, integrals and derivatives, but in reality, they're actually a fairly easy to understand program once he shows you how to use these, if you haven't thought about these before.
Right. So what we're looking at is cumulative fuel, okay? This is a Ferrari Challenge car. The data I get from the sensor is in liters per hour. And of course, us being Americans, we want to look at it in gallons, right? So what I'm going to do is, in this math channel, is I'm taking an integral of the fuel consumption. And if I just left it like that, it's going to be adding up liters per hour. And there's nothing wrong with that, except that I want it in gallons. So all I'm doing here in this math channel is dividing by 3,600 to get hours into seconds, and then dividing by 3.785 to convert liters to gallons. So pretty simple math channel, right? So how I would use this is we have this test bar at the bottom. Roger, I'm not sure I can see everything at the bottom there. Let me see if I can expand it.
Oh, it's showing on. It's going out
Is
on
it?
Zoom at least. Yeah.
All right, okay. Well, you can see the line starting at 0 on the left and going up the entire session, pretty much linear, right?
Mm-hmm.
So if I clicked on that first lap,
It starts
and
at.
I'll just uncheck this one. So now we've got, I guess this is actually not the first lap. So this is actually a second lap because we got some laps disabled. But anyway, if I looked at the first lap, I'll enable that one.
There you go.
We'll look at the fuel, and it's at 0. And if I looked at the last lap, assuming this is the last lap, the ending number is 7.9. So I know immediately that this car burned 7.9 gallons in that session. So if I wanted to see how much fuel this car was burning on a given lap, then I can just simply take the high and low numbers here, subtract them, and get a number. So 5.5 minus 4.9 is 0.6. So it's burning 0.6 gallons per lap, okay? So that's one way I use the integral function. I use the lap integral function a little bit more. And what we're going to look at here is cumulative lateral Gs. And again, this is going to reset over every lap, okay? So at the top here, we have the lateral acceleration, and it's obviously positive and negative as the car goes from left-hand corners to right-hand corners. But that, I don't really want to add up the positive and negative numbers because what I'm trying to get to is a cumulative number over the lap that I can compare to other laps. So in the math channel, what I'm doing is I'm using that lap integral function. There it is. But I'm taking an absolute value of the lateral acceleration so that I only have positive numbers, okay? So the great thing about this math channel is, one, you can tell if you've made an improvement in your driving because chances are if you've improved your driving, you've also gotten more out of the car, which means more lateral acceleration. But you can also figure out maybe a setup change. Was that a good one or a bad one? You know, because most of the time when we're making setup changes, it's a setup change that's hopefully giving us more grip. You know, I mean, you could make a wing change and get top speed, but a lot of times it's more grip. So this would verify if you've made a good setup change or not. And it can simply tell you if the track has more or less grip, you know, if the track conditions have changed over the given day. So let's look at two different laps here and I'll show you what I mean. So here's our fast lap, which is a 32.5. And by the way, this is a driver that is basically learning the car at this point and learning the track. So, you know, there's a lot of low-hanging fruit in this data. So earlier when he went out, you know, he turned a 38.7, and this is at Laguna Seca, by the way. And later he got down to a 32.5, so he picked up 6 seconds. Well, look at the difference in cumulative lateral Gs. You know, you can see that there's a huge difference at the end here. And by the way, a small difference at the cumulative at the end can actually mean a big difference in time, okay? But if you look at the lateral acceleration traces, it's kind of hard to tell exactly which corners were 100% better, you know? But if you look at the cumulative, you can see that basically starting here or even here, he really started to push the car harder, right? Because he started to get more grip. And it's about the same time of the day, so there's no big grip changes in the track. So this is why I really like this, you know? You know, it's something that's extremely measurable. And, you know, I could tell this driver, okay, let's bring up your cumulative lateral Gs by 0.5, you know? And if he does that, I guarantee you he's going to have a faster lap time. You know,
and what's really cool about things like this, the Well, you have set up some user profiles ahead of time. It's when you hit the ground running at the racetrack, you're not having to analyze deeply into a bunch of things. That you have created a performance measurement here that you can bring up real quickly and educate the folks you're working with. All the people that are watching this these user profiles are very good. You can do those at home before you ever go to the racetrack. Have them ready to be applied, which like Ray is here. That's a pretty cool little tool.
Yep. So switching gears a little bit here, if I'm coaching a driver, what I really want the driver to have as far as sensors is steering, throttle, and brake, because that's how that driver controls the car, right? So, and it's not just how much he's using them, but it's how he's using those controls. So I'll give you an example of how I use throttle and brake. What I'm going to bring up here is a coasting track map. So I'm going to uncheck one of these laps here. So what this is showing us, obviously coasting is when the driver's on no brake and no throttle, right? So everywhere you're seeing red, that's coasting, okay? If I again compare to that other lap, and I'm going to get rid of these speeds here, just so that's a little bit cleaner. So if I compare to that same lap, that 138, check out the difference between these two. So that 138 is on the inside. So look how much coasting that driver had here, here. There's some over here. So yeah, I mean, there's definitely more coasting on that 138 lap, you know, and this is what I consider a visual measure, right? You know, I can pull up this track map and immediately see if coasting is something that we need to work on, okay? And a new driver with a new track, you know, I'm not surprised to see that coasting, you know, but that would be one of the first things I would address with this driver, is to get rid of that coasting. And he did get rid of quite a bit of it, right? But let me show you the math channels for coasting here. And these are all simple math channels. So no throttle is, all we're doing is using the less than function. And I'm saying that if throttle is less than 10%, then call that coasting. So if the driver's not using the gas pedal, give me a 1. That's all this is doing. Same thing with brake. If the driver is not using the brake pedal, meaning being less than 50 PSI, then give me a 1, okay? So now coasting would be no brake and no throttle. So that's just adding those two channels up. So if he's coasting, that's gonna end up being a 2. But I went ahead and created another math channel called coasting. And I said, if that no brake and no throttle is equal to 2, give me a 1. So that 1 is what's being graphed on that track report. So pretty simple, right? So the other thing I would dig into here is one, I know coasting happens sometimes with drivers before braking zone. So that would be one thing I check. So for me to check that, I would simply bring up a brake track map. And again, I'm going to get rid of these speed measures. So you can see we have a braking zone here, braking zone here. I forgot where the other one was, maybe here. So we see where the driver is getting on the brakes. And let's go back to that coasting track map. And sure enough, we have this one here, it's coasting, this one here, and this one here. So I can see immediately that's something that we need to address with this driver. You know, he needs to, you know, get off the gas and immediately get onto the brake. You
And
know?
you talked about comparing the two a little bit earlier, and it ended up with two track maps, one on top of each other, right? Just outside of each other. In order to get that, there's a question in the Q&A box. If you just open up a second lap, it gives you that same colorized map. It just gives you two of them, right?
That's
So
right, yes.
yeah, if you add a second lap here, you'll see that, boom. What we're really looking for is what the software is trying to give you is the ability to compare the colorization of the two maps. So that, Jason,
Right.
is how we get the two maps side by side.
Yeah. So another thing I would look at with coasting is elevation changes of the track. You know, because sometimes they can dictate a driver being uncomfortable and maybe coasting and that type of thing. So I created this other user profile here, and I'm calling it a GPS slope map, but in reality, we have two different maps here. And I'm right-clicking, by the way, to get rid of these other measures here, just so it's a little cleaner for us to look at.
You right-click in the track report, and it brings up the settings.
Yeah. So here we have a track report, and what we're graphing is GPS slope. You know, and I've got GPS slope down here in a measures graph. Obviously, Laguna Seca has a lot of elevation changes, including the corkscrew. So you can see how the track undulates, and you got some pretty big drop-offs here. So these colors are showing you the same thing. And I've got a GPS track, and just to remind everybody how I get colors on this one. One, you have to have the measures per lap color unchecked. But if I go to modify the color channel, then I can choose GPS slope, okay? So the colors basically emulate what's in the track report. So now I've got a pretty good idea of what's happening with the elevation changes. And I know at Laguna Seca, the front straightaway, we have this hill going up and the track starts bending to the left at the same time. So I know that's an area that some drivers coast at. And in fact, this driver did do that. I just don't have his data anymore. So that was one thing we fixed. But that's, you know, it's a good thing to look at the undulation changes. And of course, the good thing about the GPS track map is that you can double click and drag it to see elevation changes. So it gets a little wacky sometimes, but you can see anyway the back part going uphill, and then you have the corkscrew here and how the colors are changing with that 3D map, and you can see the hill on the front straight as well. So that's pretty cool. Yeah. And if you click on this little icon over here, it goes back to where it was. A double click and it goes back to 2D altogether.
And the way that he got that started, he did it pretty quickly, but you double click on your GPS map and then push and hold the right mouse button, and that's how you kind of CAD-ish, how you can rotate that around.
Right. So now let's get to some firm measurable numbers here. So here is what I brought up. I brought up a channels report, and distance is something we haven't talked about yet, but this is very powerful. And I'll show you the distance math channel. All right, so to get distance over a given lap, we have speed at miles per hour, right? If we divide the speed by 3,600, then now we have it in seconds, and multiply it by 5,280, now we have it in feet. So now we have feet per second, okay? And all I'm doing is taking a lap integral of that, and that'll give me a linear line, and I'll show this a little bit later, but a linear line on a measures graph. Now that distance number may not exactly tie to what AIM is calculating as distance, but and the reason for that could be like this vehicle speed not being 100% calibrated correctly. You know, there's a number of different things that can cause that. But the bottom line is it really doesn't matter because it's all relative, right? You know, as long as we're using the same measurement for everything we're comparing, then it's all going to work out fine. And we're going to come to the correct conclusions. So
for coaching purposes, certainly it's going to be, you're comparing lap by lap, it's going to be just fine.
So what I've done here is I've used that distance, and I've come up with different math channels that allow me to calculate distance braking, distance coasting, distance at some throttle, distance at wide open throttle, okay? And I'm going to use math channels that I created before. So I know I have this no break math channel, and I'm saying if no break equals 0, then multiply that 1, because it's going to give me a 1 in that case, which means that the driver is off the brakes. Then multiply that by the distance. Okay, so everywhere where he's off the brakes, where he's on the brakes, I'm saying that wrong. It's going to give me a 1 when he's on the brakes. Everywhere where he's on the brakes, it's going to multiply that 1 by the distance. Okay. Same with no throttle. We got the, if it's less than 10% throttle, then give me a 1, which means that if it's more than 10% throttle, give me a 0. So that's going to be when he's on some throttle. And we look at distance throttle, it's the same type of deal. If it's equal to no throttle equaling 0, then that means he's on throttle, and we're going to multiply that by the distance. Okay. Coasting, same type of deal. If coasting equals 1, take that 1, multiply by the distance. Distance wide open throttle, what I'm calling wide open throttle, is greater than 98%. So if the pedal position is greater than 98%, that's going to give me a 1, and again, multiply by the distance.
Just to take a little bit of panic out of some of you that are watching this, and he's going, and by design, he's going through this fairly quickly. We have a lot of information we want to continue to get through in this YouTube video. What I do want to share, number one, this is going to be recorded. We put it right out on YouTube. You can rewatch some of these things. But even more important is when we're going to put this data up. Robbie's going to give you a link right now if you want to go ahead and download it, or you can wait till it's in YouTube. The data files that he's using here, and all these user profiles that he's using to select and set up his screens, and of course the math channels, they're all included, will be included as a download. So if you're having some trouble, think you're getting overwhelmed by just some of the, if you haven't played with math channels much, and you're kind of getting frustrated, maybe he's going fairly quick, don't worry, we're going to give you all of these cool examples as a download file, in the chat box here in a moment, and as well as in the YouTube description box when the video is up and running. So that'll help you come back in, bring up the video, and click right along with him if you're interested in digging in deeper. So just wanted to share that, Ray, so everybody would be up to speed.
Yeah, good. I do see there's a couple of questions here. I am assuming there's no traffic, but certainly that can affect coasting as well. And that's something to look into. Yes, you can absolutely do this with longitudinal Gs. You would probably want to do an if statement that says, like, if your longitudinal Gs are greater than 0, then add those up, and that can either be your braking or your acceleration, whatever you want to look at. So yes, absolutely, you can do that.
Exactly.
But here we have these 4: distance braking, distance wide open throttle, distance coasting, and distance throttle. Now, when I was looking at this, I saw something interesting. So this driver, with fastest lap was a 32.5. 2 laps before, he did a 33.0. But notice in that lap, he had more time. Really, distance and time are interchangeable here, right? More time and more distance at wide open throttle, which usually, if you have more time spent at wide open throttle, that's going to be a better lap. So that's kind of interesting right off the bat. On that slower lap, he actually braked less. His distance coasting was a little bit more, not so big of a difference in distance throttle. So why is that? It got me to bring up a lap compare profile, and I'm going to bring up those 2 laps. And I'm going to uncheck this other one. All right. I think those are colors we can see. So, if you look at the time variance, there's a lot of up and downs here, right? So it's kind of hard to tell exactly, why that driver lost half a second, because there's there's so many different things happening. Now I can see there's a little bit more brake pressure here. And by the way, the fast lap is in green and the slower lap is in red. So yeah, I mean, I can look at every one of these and dig deep and figure out, you know, what exactly happened in each case. But I kind of want to stay at a higher level right now. So it makes, you know, just thinking about this makes me wonder if he just slowed the car down more, you know, on that slower lap, right? Because if he was on the brakes harder, that would slow down the car more, even if he's not on the brakes as much, right? So let's go back to the channels report. And by the way, I call this channels report distance throttle brake coasting, TBC. So let's add brake pressure here. If you don't remember, this is how you add and remove channels. And I'm just going to go down here and I'm going to find the ECU brake pressure. And I'm going to look at average, if not zero. Okay, so that's going to eliminate all the times where he's not on the brakes at all. And I'm going to say, okay. So that's going to bring that in. And sure enough, look at this. He's averaging more brake pressure on that slower lap. So that would be a pretty good indicator as to how he can have more wide open throttle and yet turn a slower lap time.
Yeah,
So
this racing data sometimes is not simple, right? You'd think that, gosh, if you're on the gas longer, it's an easy call, but it's such a multi-dimensional thing that creates a lap time. So digging in and figuring that out is very important. So a cool little tool you figured out there.
yeah. So anyway, that's about all I want to talk about with the Laguna Seca, Roger.
Okay.
So we can switch over to the Homestead.
Go ahead and start switching that over. Close that down, and then I think I'll start up when you get that data up and running. I think what I'll do is we'll start another. We'll throw in another poll. And while you're doing that, there somebody mentioned in the chat, and I thought it was a great question. Would love to see a future poll with what type of racing are people doing. We have done that in the past, and I'm not set up to do it right now, but I will in the near future build another poll, and we'll maybe the next time we do this we'll have that as one of our polls. What type of racing are folks doing? Let me launch a poll right now, though. However, of when analyzing your data, what functions do you use the most? We've used this poll the last I think last week as well. It is a interesting thing for us to understand. And by the way, it's multiple choice. So if you I'd rather you not just click on all of them, but pick the ones that you use, quite a bit, maybe the top 3 or 4. This also helps us a lot when it comes to future webinars. We also have some other ones that different ways of getting us that information, but this is the one we're going to use today. So fill that in. We'll let that go for just a minute or so. Ray, while that is kind of finishing up, maybe you can give us just an overview of not just this screen, but what data are we looking at now? Where are we at?
All right, so we're at Homestead. And last seminar, I used some of the same data, actually.
That's right, yeah.
But what I've got here is data from a pro driver and data from a layman driver, so to speak, a gentleman driver.
Perfect.
So we're going to look at some of the differences between these two drivers. And we're going to initially stick with this channels report.
Okay, let me go ahead and let me end the poll before you jump deeper into it, and then share the results of this poll for everybody. Okay. And should be able to take a look at it. There you go. Just so everybody knows where we're at. YouTube, when we record this, it doesn't bring this screen up, so I like to call it out a little bit. The measures graph is kind of the core of a data analysis software. The squiggly lines, where Ray started, is used the most by most people. 91% of those that voted included that. The second one is the time compare bar. It's the bottom of the measures graph. It is a powerful tool. Ray has already even pointed it a couple times so far today. The third place one is split reports, and then channel reports, and math channels right in there, all about the same, in the high 30s, low 40s%. So there's a pretty good idea of how people are using the software. We use this when we are figuring out which functions we want to continue and give more training on. So I appreciate everybody doing that. I'm going to stop sharing that result there, and then get ready for the next poll. And then Ray, as you're kind of bumping along, the next thing that you want to talk about is we're still in a channels report, but we're at Homestead with two different drivers now. Where we've been at Laguna, we were basically one driver against his best lap versus another lap. In this case, you've got the pro driver and the gentleman driver, and we're going to be able to compare kind of some cool things. Go ahead and take that over.
Yeah, I'm going to answer a couple of questions here too, Roger. So one question was, why do I use distance versus time? In reality, it's very difficult to calculate the time, but I do think they end up being about the same. So the distance is just much easier to come up with a number, and that does relate to time, right? Assuming that the driver's driving the car the same way.
Personal preference, though, you could easily set those math channels up to do either one, or these channel reports to do it either way. So,
right. If you don't have an ECU, so you don't have all these, throttle sensor, throttle brake steering sensors, it's very difficult to get coasting out of the data that you have. But you can use your lateral and longitudinal G channels through GPS and come up with all this stuff. Just use, you can certainly take an absolute value of the lateral Gs and can use if statements to get plus or minus longitudinal Gs and come up with ways of analyzing that data. So yeah, that's what I would do in those cases.
Sherm, if you have any more questions about that, we've got a math channel video, a little quick Zoom meeting I had with a number of people, and we talked about how to build math channels using some of the GPS-based channels. And I also, you'll have my email address at the end of this. I also have some math channels that are the coasting and the acceleration and a lot of the stuff that's fairly close to what Ray has shown here, already built for you with some math channels that I can send out. I've sent it out to hundreds and hundreds of people. So if you, I've got some that are based on just on GPS based stuff, if you don't have those channels, or if you have some ECU channels, or a data logger that allows the analog inputs where you can put a throttle position sensor, brake pressure, steering, we have the math channels kind of set up for those as well. So anybody that wants those math channels, just drop me a note and I'll email you a nice little email about them, how to use them, and then with some links to videos with some more information, plus of course the importable math channel files as well. So there you go, Ray.
Okay. One thing I didn't mention is that these channel reports with these different distances is also a great way to measure consistency, right? If you're not seeing much variations between these, that driver is very consistent, and then you have the distance of the entire track as well. So yeah, all these you can compare and get a pretty good idea of consistency. But anyway, we're looking at Homestead data now, and again, this driver, 1 is the gentleman driver, driver 3 is the pro driver, and I can flip back and forth between the two here. Pro driver only did 2 laps, so but he went significantly faster in those 2 laps. And just look at his distance here, 351 and 348, so pretty dang close, right? And his lap times were within a tenth. So that's how good this guy is. So if I do a compare between these 2 drivers, I can do the same thing I did before. Look at the distance braking, 2471 for the pro, 2548 for the gentleman. Not a huge difference there. Distance of wide open throttles, 6689 for the pro and only 5855 for the gentleman driver. Huge difference, right? Distance coasting, about the same, 801 and 841. And if you didn't catch on to this, yes, the pro driver did coast. Sometimes coasting is not bad, If you need to wait for those front tires to have grip, after you've gotten into the corner, a little bit of coasting is not going to be bad. If you try to go to throttle too soon, you're going to get more understeer, and the car is going to wash out. So this, as we're going to see, this pro driver knows when those front tires have grip, and he was just waiting for those tires to get the grip. Distance throttle, which again includes the distance at wide open throttle, is 8405 or 806, and then 9038 for the gentleman driver. So how can the gentleman driver be at some throttle quite a bit more, 600 feet more than the pro driver, and yet be so far off on the wide open throttle? So I'm going to show you how one way to look at that is. So what I'm going to pull up here is a throttle histogram. And AIM's got, some great tools that a lot of people don't realize are there. And this is the true power of the software, right? You can choose different ways to look at the data and get different things out of it. Sometimes you can get different things much quicker. So here's a throttle histogram, and if you right click on it, it pulls up the little menu here. I can either choose time on the time against the whole lap, or percentage. In this case, I'm using percentage of the lap. And I can choose the number of bins. I like using 10 for throttle, just because it gives me bars from 0 to 10%, 10 to 20, on, so on and so on. And I like it to give me the bar values. So those are these values here you're seeing at the end. But the real power of using this histogram is comparing the two drivers. So if I do a test compare, now the pro driver is in blue and the gentleman driver is in orange. And the pro driver was between 90 and 100% throttle for half the lap, 50.5% of the lap, whereas the gentleman driver was only at full throttle, 42.7% of the lap. So right there, that's a huge difference, right? But check out this, 0 to 10%. The pro driver was actually in that area more, pretty significantly, 32.3% versus 25.1%. So the difference is between 10 and 90%, right? And especially as 10 to the 20. The gentleman driver is spending way more time in this 10 to 20%, and he's not as confident about going to full throttle, right? When the pro driver decides he's going to get the full throttle, he pretty much gets there, and that's the difference. That's why the gentleman driver can spend more time at some throttle, but not as much time at full throttle. Okay, so it's all on how they're getting on the gas.
The earlier statement was illogical at first, right? But with this, you can see by the 10 to 40%, basically, that those three bins, the orange chunk is substantially more. So as you said, the amateur driver is coming off throttle, off of zero, and is hesitant, about getting ready to go, and then where the pro driver has, by the graphs here, the way those things stack is the larger of the two is the one that's behind. So the blue one on the top and the bottom is the bigger of the two, because you see it. And so between 10 and 40%, the orange one is the larger of those graphs. That's why it is the one that's farther to the right. And then the blue stacks up on top of it. So just an interesting way of looking at it. And I think you've got another couple of ways of even digging in deeper.
I do. One thing I really like about this is that it's a measurable item, right? I can talk to this gentleman driver and say, hey, let's try to get you up to 43% here, 44% in the 90 to 100% range. And he could be sitting in the car waiting to go out again. I could download the data, pull this up, and see if he's achieved that goal. So this is what I mean by being able to do it quickly. So now we're going to get even deeper into this, and we're going to look at driver smoothness, okay? And there's a lot of confusion about driver smoothness. At least I've seen confusion. A lot of people automatically think it's just how you use the steering wheel, being smooth with the steering wheel. But I'm going to show you it's more about being smooth with the throttle and the brake. And I have this math channel called Driver Smoothness. And this is where we're going to get to using that derivative channel function in the math channels. So I've got these three math channels. I've got steering velocity, brake velocity, and throttle velocity. And all I'm doing is taking the derivative function and just taking derivative of them. And that's giving me the rate of change. So velocity is rate of change, right? So that's all I'm doing. So very simple. So here, I don't know why we don't have a steering velocity for him, Roger. I don't know why. That's weird.
Yeah, maybe bring up the math channel real quickly, and let's maybe we'll do a quick fix. Let's take a look at it. Go to that driver. Steering velocity. Derivative steering. Is the other one's working?
Yeah.
The other driver, the 001. That's the one that's missing it, right? Click on the test next to it across there. There you go. And
it's the same thing.
Yeah, interesting. Go ahead and open that back up and then click on the OK. That'll reapply the math channel.
Well, I'm going to just click on a different user profile.
Yeah, it's working there.
Did we get it? No, we still didn't get it.
Yeah.
All right, so we're going to focus on throttle and brake, which is a shame because there was a lot of good information in the steering. But look at how smooth this driver is with throttle application when you compare. So this is throttle velocity here. So the up is when he's getting on throttle. The down is when he's getting off. So all these real little movements is just smooth throttle application. Okay. Now let's look at the gentleman driver. See how much more change that is? So every time he's getting on and off the throttle like that, that's transferring weight of the car, and that's basically making the car unsettled, right? You really want to keep the car balanced. And for the brake, again, the pro driver is getting on the brakes super hard and then easing off. And the interesting deal with this brake trace or brake velocity trace is that he gets on the brakes hard. That's that quick up. And then as he's getting closer to the corner, his brake release slows. Okay. So he's just keeping that car balanced with the brake pedal, right? And if I look at driver one, the gentleman driver, you can see many more variations in that brake velocity. So that's a huge difference. Now I'll tell you, in the steering velocity, what we saw was for the pro driver, there was many more undulations with his trace, with the steering, than there was with the gentleman driver. Because what he's doing is he's balancing the car as he gets into a corner, and then as he's in the middle of the corner, he's feeling the tires moving underneath him, and he's making a lot of quick yet small steering corrections to keep that car balanced. So that's what you're going to see when you're looking at driver smoothness. Those are the things to be looking for.
Let me take over something for a second here. And there's a question that maybe you can handle. Why I just do something really quickly in the Q&A box. Take a look at that. What do you think about what kind of cars and where are you at?
This is a Ferrari Challenge car. So 488 Challenge car, 670 horsepower. You got it back?
Yeah. So the Ferrari Challenge cars, so they're both the same, both spec cars. So the only difference is the driver inputs. That's why this is such a great tool to be used in this particular class.
Right. So now you can see if I flip back and forth, the difference between the pro driver and the gentleman driver and the steering. So pretty huge difference, right? I mean, the pro driver just has the confidence to keep that car on the edge, and he's just so smooth with the throttle and the brake. And that's what's allowing him to do it. So if you see big differences in speed traces, it's really good to dig a little bit deeper and see how that faster driver is driving the car. And this is one way to do that. I actually kind of think of this as the driver's signature. So the other thing I did here was so we can see the normal traces is now I've got the normal traces up and I've got the velocity traces in gray. So you can see this is the pro driver. You can see his little movements, but check out this one where he went to quite a lot of steering lock here, and these little undulations, you can see that showing up as quick velocity in the steering velocity trace. So that's what I was talking about. And notice how he's on throttle at this point, right? He's gradually bringing the throttle up, and this nice smooth throttle application is showing up as just barely little lines and the velocity. Okay, so as you see these on top of each other, you know, it makes a lot more sense.
This is a fantastic way of looking at the data. I have not, when Ray showed this to me, I hadn't done this before, where you kind of gray out one channel that's in the background, and it really takes that derivative, which sometimes is not totally logical at first, but it's the speed of change of the steering in this case, right? So we've seen all these gray lines just jumping all over, and you think to yourself, well, that's not smooth. But in reality, if you look at like Ray was mentioning, every place where he's turning in and where the car really does need the smoothness, it is very, very smooth with very little of the derivative channel showing. And then when he's balancing the car on that knife's edge, then you start to get that change. Having that grayed out channel in the background saved as part of his profile, that makes this secondary way of looking at these same two channels just very, very powerful. And we'll see that when he adds the other driver as well. Great way of looking at it, Ray. I really like this. Thanks.
So, you know, everybody's probably heard about the right shape of a brake trace, right? And you want that initial brake application then tailing off. Well, the brake velocity trace shows you why that trailing off is important, right? Because in this particular case, you can see how the line is pretty straight up and down, and that relates to this here, that little spike coming off. But then him slowing down the brake release is what creates that tail.
Perfect. You know? Looks good.
And if you look at driver one, same thing, right? You know, so we got that smooth steering, and you know, so you're not seeing any real jagged lines here. You got a little bit here, but not a whole lot, not compared to the pro driver. And if you look at his throttle trace, you know, it's a lot noisier, and that noise is showing up in that throttle velocity. And same with the brake velocity, right? They're just not as smooth as that pro driver. So, so anyway, I really like looking at this. This is one of the first things I look at if I'm working with a new driver, because if I see that the driver isn't quite as smooth as he could be, then I know that's something that I can work on with them and get that driver faster just by getting him to control the car better.
Yeah, Andy has a question there that fits in perfectly with where you're at here. But how do you balance when the guy that is thrashing the wheel, the steering and the gas pedal is 4 seconds faster? There's a little bit of a counterintuitive, especially on the steering, the one that we're looking at right now. Yeah, this is the amateur driver. It's certainly a lot smoother, but when you are, you know, 5, 6, 7 miles an hour, certainly 5, 6, 7 seconds per lap, and then the same number of miles per hour probably in that corner, that driver's not driving at the limit. Of course, he can drive it like a slot car, right? So but yet his feet are doing things that are not super smooth. You have to apply this derivative and this different bits of information in different ways. What do you think about that, Trey?
Yeah, that's exactly right. That's why I was saying, that's why the steering looks so jagged with the pro driver is, again,
at the limit,
because he's at the limit of the car. The car is moving underneath him. He's got to make those steering movements fast in order to keep that car underneath him. And he's not turning the steering wheel a lot, right? It's just these little jagged
little changes.
Yeah.
But very quick.
But they're quick little changes. And that's where the steering velocity trace shows its value.
Yeah, this one takes a little while to learn. That derivative takes a little while to understand because sometimes they can look like they're very large, but in reality, if you look at which is why this is great to have the channel with the gray behind it, the derivative in gray behind it, because then it even cements it even deeper that this driver's not really whipping the wheel around a lot. He's moving it slight bits and very quickly. So while you think it's not smooth, it's actually, the driver is doing a good job.
Yeah, and that was my point from the beginning. Is really the smoothness comes from the throttle and the brake more than the steering.
Perfect.
And that's what a lot of people lose sight of when they hear smooth is fast. You could be smooth going in with the steering, but if you're on the edge, you're going to have to be moving that steering wheel quick to keep the car underneath you, and you're going to have to be very gentle with throttle and brake in order to minimize the weight transfer.
Perfect.
Cool. So that's all I have, Roger. I think that's
perfect. That was a lot. You and I know, and I feel for some of you, and I seen a couple of comments that went by, fairly quickly. We are well aware. It is not lost on us that we go through these things really quickly. But we try to balance this thing where we're trying to present a lot of good information, and then yet allow you to get it. So that's why the videos go up on YouTube right away, and where you can go back and rewatch it. And then we try to, in so far in every case, we've gotten the okay to share the data, the user profiles, the math channels, everything with you. So if you, my suggestion to people when they're watching these webinars is more or less, download some stuff that Robbie and the guys are putting up there, is some of the links, but boy, just kick back and watch and see what maybe with a notepad, and say, oh boy, I really liked what he talked about, at this time, or that particular function. Go back in, grab the data if you want to then practice it and see if it truly does work for you. Grab the data, import it, and rewatch the video and build it with them. That, I think, that ends up being the secret to getting as much as you can out of us throwing just a ton of information and a ton of different processes at you. So keep that in mind as you go. So I appreciate it, Ray. I know there's a lot of work involved in putting these things together, and that it is great that you were able to do that. Let me do this. Let me bring up another poll before we start to close things out, and of course we'll want to share the information with you. This is something that we like to ask, and is what are the your top 3 topics you'd like to see for future AIM webinars that we've been doing. We've got these scheduled at least through the middle of July, and we may continue to push that forward. We'll see how the numbers continue to go, if you guys are enjoying them and getting good value out of them. But as of now, we're going to continue on. But what we do, though, is we take this poll specifically, is one we really look at very closely every time. We'll let this run for another minute or so, and then we'll show you the results. So answer those questions. What are the top 3 things you'd like to continue to see another webinar about? So while we're doing that, I'm going to give a different share, get back to the presentation materials, and while we let that go, if it's in your way, go ahead and just after you answer, hit the submit button, and then that box will go out of your way, and I will reshare the results here in just a moment. Like I've said a couple of times, we have this YouTube site out there, AIM Data, and we put up all of these videos that we're creating with these webinars. We have 90 of them currently up there right now and growing. This one will be up within an hour or two, and go there and watch number one, all these webinars that you may have missed some of them, but there's also just another ton of other videos in there that answer a lot of questions that I see in the chat sometimes. Sensor calibrations and gear position and updating your firmware, that if it's a question that we've gotten a lot, we tend to build a video and put it up on our YouTube site. So keep that in mind, and go visit there and browse around a little bit and see what's out there for you. We're really a customer support company that happens to sell racing electronics, provide support for those things. Boy, we're all tickled that you and us all are getting out to the tracks and starting to get back out there. I know there's a number of our folks that are heading to their first races this coming weekend, and we hope to see you there certainly. If you have any problems or questions, obviously you have a lot of our emails, or there's an 800 number there for you to call. We're there to make sure you get the best value out of your investment of these pieces of hardware. So let us know how we can help. So as part of this, I'm going to end that poll right now and show it to you why we're talking about the next webinar. The poll results showing data analysis, always a big topic. Really, these webinars are really very, very easy to, and probably the right way to talk about the analyzation of the data, because of just the being able to project the software and talk about it. And that's what most of you want. That has been the top one of our polls all the time. 76% of you said data analysis. Number two there at 35% is configurations. We've been chewing on that. That's probably going to be within the next 2 or 3 webinars will be another configuration webinar. Number 3 here, ECU protocols is right there. Ironically enough, here we're going to talk about that next week. And let me stop sharing those results so that we can get them out of the way so you can see there. There we go. The next one, our guy that there's been putting all those links up for you in the chat box, Robbie Yeoman, he's gonna give us a talk about CAN 101, introduction to CAN bus technology. This is something that's been we've been getting a lot of messages from. We do these polls, and that whole ECU protocols and expansions and some of the stuff that uses this technology continues to rate higher every week. So people are really looking forward to this. So Robbie's going to present some stuff. We've got an hour, and we're going to put some stuff in. We really do expect this is not going to certainly be the end all of talking about CAN bus technology. It's going to be an introduction to it, and then and it'll be part 1, right? So expect to, and based on your feedback from next Tuesday is when do we bring in another one, and when do we dig in more. So if you're interested in this kind of technology, and even if you're not, jump in and let's listen to it. Robbie's going to teach us a little bit about this and using the AIM software and show some of the power that we certainly have built into our processes with this and more of what's coming. So look forward to having Robbie co-host. This is going to be one of those that I'll probably be pretty darn quiet. Robbie will be teaching me a lot as well. So this is we look forward to this. So the last thing is thank all of you again for coming. It's been a great time. The contact information for myself and Ray. Ray is gracious enough to offer up those data files, those user profiles, math channels, and everything that he's built there. Ray also has a service where he provides some of those. So if you have anything in your mind that you might want to do but don't know quite how to get there, drop Ray an email and he'll get back to you. There's my contact information. I mentioned math channels that I can send out to anybody that wants to have a bigger overall list of some math channels, some things that we do. I'm more than happy to freely distribute those out to everybody as well. Ray, again, thank you. Is there anything you'd like to add here as we're kind of closing things down for the day?
Yeah, just believe it or not, that's actually just kind of scratching the surface of what can be done.
No doubt.
So yeah, there's a lot more that can be done, and you can do it too. You just gotta, play around with it, be creative, try to figure out, what your ultimate goal is as far as a measurement, and figure out how the data can get you that information.
Perfect. I appreciate it, Ray. I appreciate your style of presenting the information. You've put a lot of work and effort into these, and then make it understandable for the folks that are watching this. So I do appreciate that. Again, there's our contact information. Thank you all for coming, and we look forward to seeing you next Tuesday for CAN 101.
Thanks, everyone.